tick. Yay! It's working so far. Okay, so these are all permutations. A combination is when order does not matter. So combination, if they say NCR, okay, that's called, so that's kind of like that example that I gave. Order, the order doesn't matter. With a permutation, the order does matter. Order doesn't matter. Okay, so you see combinations in like picking committees, picking committees, picking, is that how you spell committees? Picking committees, picking marbles from a jar, things like that. So if I say I want from 5 people, I want to choose 3 people for a committee. Sometimes they write it like this, 5 combination 3, but sometimes they also say 5 choose 3. Okay, so if you're like playing cards is a lot of, cards come up a lot in combinations. If they say how many different ways, how many different poker hands are possible? How many cards do you have in a deck of cards? 52. How many cards in a poker hand? 2. No, that's blackjack. How many, come on, man, you gamble, no, I'm just, how many cards in a poker hand? Do you guys play poker? No.
There's so many different kinds of
There's
poker,
5,
actually.
okay? 52 combination 5. Sometimes they say 52 choose 5. That's all the different possibilities for poker hands, okay? So 5 combination 3 means I have 5 people, I'm choosing 3. Sometimes they write it like this, 5, 3, with just like that, and it's understood that it's a combination. 5, but this is 5 combination 3 or 5 choose 3. If it NCR means n factorial, okay, over n, if it were just n minus r factorial, that's a permutation. But then I divide by r factorial, because r factorial is, so let me just do this one, okay? So if I want to know how many different 3-person committees are there if I have 5 people, right? I have 3 seats, right? If it were just a combination, I mean just a permutation, I'd have, oh no, I'd have 5 choices for this, right? I'd have 4 choices for this. I'd have 3 choices for this, right? So say I have person A, B, C, D, and E, right? So say it turns out that I chose person A for this seat, person C for this seat, person E for that seat, right? So there's 5 times 4 times 3 different ways that I could have arranged these 5 letters. But I could also call this CAE, right? If it's just, I'm just choosing a committee, it doesn't matter. I could also call this CEA, right? I could also call this AEC, right? I could also call this EAC, or I could call it ECA, right? Turns out there are 3 factorial ways to arrange those 3 positions for those 5 people. So what I have to do with a combination is I have to divide by the number of arrangements of those 3 objects. So in this case, 5 combination 3 would be 5 factorial, okay, over n minus r factorial, which is n minus 3, which is 2 factorial. So basically what this 2 factorial does, let me kind of show you literally what it does. 5 factorial means 5 times 4 times 3 times 2 times 1, right? 2 factorial means 2 times 1, right? 2 factorial is 2 times 1. 3 factorial means 3 times 2, 3 times 2 times 1. basically what this does, this is the permutation. Basically what this does, it just sets it up so that I only have, whoops, did I cross out the wrong thing? I crossed out the wrong thing. Let me go back. Basically, what this does is it cuts off those last two spots, right? So that I just have the first three digits of that arrangement, right? What this does, this 3 times 2 times 1, sorry, that should be over here, is it divides by the number of arrangements of those objects. Yes? So let's just look at an example. Where's an example on that sheet? Okay, so where's another example? 6 people wish to play bridge, but only 4 of them can play at one time. If they decide, let's grab that. Partial. 6 people wish to play bridge. I don't know about bridge. Okay? 6 people wish to play bridge, but only 4 of them can play at one time. If they decide to play a game, each group of 4 players, how many games will they need to play? Okay? So, is this a combination or permutation? Combination or it's a combination. So this would be 6 combination 4, right? So it's 6 factorial divided by 6 minus 4 factorial, which is what factorial? 2 fact. Good. There's my little squiggly thing. Okay, over 2 factorial over 4 factorial, because that's the number of arrangements of those things. Okay, so to do this, I mean, you could do it on a calculator. I'll show you in a minute, but it's nice to know how it works mathematically. So 6 permutation 2 means 6, or 6 permutation 4 means 6 times 5 times 4 times 3. 4 spots for 6 people, but then I have to divide by the number of arrangements of those spots, which is 4 factorial. 4 times 3 times 2 times 1. Yeah? No? So what happens with a lot of them you could do them without a calculator, because look, 4 and 3 cancel out, right? Because everything's being multiplied. What else could I cancel? 2 goes into 6 how many times? 3. So what's my answer? 15. Right? Watch your calculator. So let me get my calculator here. Okay. So gotta find it first. Where is my calculator? What's that? Oh, there's my weekly memo. You don't want my weekly. Here's a calculator. So if you have a TI calculator, most of you do. I'm not sure how they work. Anyone not have a TI? Anyone have a different brand? If you have a different brand, we'll figure it out too. But so if I want to do a combination 6, combination 4, 6, then I go to PRB, okay, which means probability, and then I go down to NCR, not NPR, right? NCR, and then I just hit 4, and then I hit enter, and I get 15. That's 6 combination 4. Yes? Easy enough? Okay? But you have to determine whether it's a combination or a permutation. All right, so let's look at another one. Oh, here we are. How many different 5-card stands can be made from a 52-card deck? How would I do that? Who can tell me how would I write that as a combination or a permutation? Whoops. How would I write it? 52 combination 5, right? So that's kind of a tricky one to figure out. So I'm just going to grab my calculator. I'm going to make it bigger. View, size. Let's do a large emulator. Okay, so I'm going to do 52 probability combination 5. And I get, whoa, what's that, million? 598,960 different possible card hands that you could have, okay, with 52 cards. But that's like, so the order doesn't matter, right? When you're getting cards, it does, you know, sometimes you'll order them yourself to figure out which way they go, okay? How about this one? How many different you guys try this one. Problem 11, how many unique 3-person committees can be made from a staff of 15 people? Go ahead. You can do this. 16 people, right? Is that what that says? 16 people? Ian, tell me the answer.
About 560.
Is it 560? Is that what you got? So that's just 16 combination 3. Okay? 16C3. You should also know how to write that out longhand. How many spots do I have? If I were doing it by multiplying possibilities, how many choices do I have for here? 16. How many choices do I have for here? 15, right? How many choices do I have for here? 14, right? So I have 3 spots, but then I have to divide that by this number of arrangements, right? Which would be 3 times 2 times 1, which would be 6, right? So if I did that, I would get, is it 560? Is that what you said? 560. Okay. Next one is kind of adds a little bit of spice to the mix here. So with this next one, sandwiches. So this is kind of a combination of combinations. Choice for a sandwich are 4 different meats, 5 different cheeses. How many different sandwiches of 2 meats and 2 cheeses could you make? Okay? So, sure. Okay? How many different ways? So sandwiches are 4 different meats and 5 different cheeses. How many different sandwiches of 2 meats? So how many ways are there to pick my meat choices? How many meats do I have? 4. Combination, how many do I choose from that? 2. 4 combination 2 for my meat choices times, right? I have 5 different cheeses, yes? Combination, and I'm choosing 2 of them, right? So it's 4 choose 2 times 5 choose 2, which comes out to be 4 times 3 divided by 2. That's what this is, right? Because it's 4 times 3 divided by 2 times 1, and this is 5 times 4 divided by 2 factorial, which is just 2. So this is going to be 12 divided by 2, which is 6. This is going to be 20 divided by 2, which is 10. That's going to be 60, right? Okay? That's why Chipotle is so successful. I own stock in Chipotle. I'm up a lot. You know why? Well, until everyone got sick from Chipotle food. That wasn't good. But they're back in business now. But seriously though, no, so like if you go, they have like 6 different meat choices, right? Or something like that, or whatever your fillings are. So you have 6 choices for fillings. You only have 1 choice for cheese, right? But then you have different beans, right? You have different rice. You can get burrito, taco. So the ingredients they have are relatively simple, but I always get the same thing every time. But you could go in there and mix it up, so there's like thousands and thousands and thousands of different combinations. Oh, maybe I'll try the chorizo today, you know, or maybe I'll try don't try the veggie one, it's kind of gross. Have you tried that one? What's it called? Have you tried the veggie one? I forget what it's called. It's like veggie tofu. Who's had the tofu burrito at? But anyway, they have tons and tons of different choices, but relatively limited amount of ingredients. So they have lots of different combinations they could order, and so they could mass order all this stuff, but then they could still provide a lot of variety. Plus, they're really fast, you know, not that expensive. All right, so I think I think I'm just gonna stop here. I was gonna have you do the choosing card probabilities worksheet, but I think we'll just stop this, and you can just work on finishing that first worksheet I gave you, the 1 through 10, and work on your nets as soon as I finish grading these, and then we'll talk more about card probabilities and dice probabilities, and work on your areas for your nets some more tomorrow. Okay, so you'll could have time to work on that stuff. Okay, so I want to stop. I'll just have to revise.